Welcome back. So now let's move on to the guided practice session on linear regression. So in the video session I would have discussed about linear regression and what it is. So as said specified there, linear regression is just a straight line, a mathematical function which will form a straight line. So now I say y is equal to ax plus b, and here y is the response variable and x is your predictor variable. So, linear regression, it is based on finding a relationship or creating a model based on two variables, where one variable is considered to be a response variable and the other variable is considered to be a predictor variable. Fine. So, this a and b are the coefficient values, or we call them as intercepts. So, all these basic concepts we had seen in the session. So, now let us move on to the demonstration of this. So, for example, as whatever was discussed in the session, we had one vector which is called as weight. So, as specified, I have some sample values which are the weight of few people and their corresponding height. Fine. Yes. Now, I say weight is a numeric vector. Now, I say weight of a person. Suppose I have some weight like this. Yes, so I say 65, I also say 67, and I say 37, then I have something like 87, then I say 64, all these. So, how many values are there? So, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so the height should also be having those 9 values. So, see to that you have that. Now, I say 145 for the corresponding one, 140 for this, then 160 for this, then I say 180 for this, then again 170, then 172, then I have some 140, then I say 190, then again I say 156. Fine. So, these are the values. Now, let us see. So, 3, then you have 6 and 9. Yes. So, now these two vectors, the two numeric vectors weight and height, are created. Okay. So, now if I have to go for creating a model for this, now let me create a model. So, as I said, it is a linear model. So, I say linear underscore model is equal to, we know the function lm, yes, and I have these two. So, I say weight and the symbol for that, then you have height. Yes, fine. Now, the linear model is done. Now, let us see what is this. Now, let us see what are the intercept values. Yes, see, you have got this formula, you have created a formula here, and you have the intercept value and you have the height. Yes, fine. So, now this is going to be your formula. This is how the coefficients are calculated. Now, if you have to predict something for a new data, yes. So, now I say suppose new and I say height, yes, new height is equal to, and I say I create a data frame and I say my height value is going to be, for example, 154. Yes, fine. So, height is 154. Now, let me try printing this new height. So, I say print new height and let me check. So, 154. Now, you want to predict this, predict the weight for this person, right. So, I say predict, and now we had already created the model. Based on this model, you have to predict the height. Yes, fine. So, now I say new underscore height. So, based on this linear model, whichever we created before, we want to predict the weight. Okay. So, now when I say this predict, see, you are getting the weight as 51 point something. So, this can also be assigned to a variable. I can say new weight is equal to, and then you can print new weight. So, when you assign this, obviously it will not print. When you don't assign, directly give the command like this, it will automatically print the value, otherwise you have to print it separately. Fine. So, this is the usage of your linear model. So, what we had done, just we had two numeric vectors, one to be the weight, the other one to be the height, and you want to predict the other. And you have to have in mind, in this case I am going to predict the weight based on height. If suppose you want the other way, so what you can do, again you can say linear model 1. So, you want the other one, suppose I say height and you want to go with weight. Yes. So now let me say again predict, and I say the same thing. So instead of creating separately, I am going to combine these two statements, that is creation of the data frame and predicting it. So now I say linear underscore model 1 comma, and I have to give a value. So I say data dot frame of, and I say something which is my here in this case it is weight. So I say weight is equal to, suppose I say 84. Yes, fine. Now see, you have got the height which is 185.4507. So if you want to predict the height based on a weight, then you have to create the formula like this. If you want to predict the weight based on the height, then it has to be the other way. So which we created before. So weight, this one. Fine. Yes. So this you have to be very cautious when you create this formula for your linear regression model. Okay, fine. So now this is with your usual numeric vector. So in the video session I would have said that you can also have data frames. Yes. So now we know that there is already one data frame which is built in. We call it as empty cars. Fine. So this is a data frame which is built inside your R console or in your R environment. You can just check out. So I say head of empty cars. Empty cars is a data frame which is already available with some values, right? Yes, fine. So now you have so many columns here. Now if I suppose I say I want to predict the mileage based on the weight of your vehicle. Yes. So now I can say model is equal to, now I can say LM of, and what is this? So you have something which is the value. So first I have to take my input. Now I say input is equal to, and I say empty cars. How do I select a specific column? So you know all rows. So I say comma and C of, and I can say the column name. So I say MPG comma, I say weight. Fine. Yes. So this is my input for my linear regression model. So I say here head of input. See, you can see only MPG and weight. Fine. Yes. Now let me go for designing my model. So I say LM of, what is this? Suppose now I say based on weight I want the MPG. Yes. So I say MPG and I say weight. Fine. So now in this case this MPG and weight, it is a part of your data frame. So I say data is equal to this input. Fine. So this is the variation of your LM function. See, you have something which is called as data is equal to. So if you are going to use a data frame, in that case this you can go ahead. So you can have some subset of your data frame and you can go for using it. Fine. So now let's print the model. So I say printing the model. See, you have got some weight and coefficients. Fine. Yes. Now if you want to go for predicting something, so I say predict. I want to predict based on the model which is created, and the new value I am going to say data frame of, what was that? Now I say weight is equal to, and I say my weight is 3. Fine. See, I've got the mileage. If my weight is 3, then my mileage of the car can be 21.25. Yes. So the other way also you can try. That is with the weight, if you want. Now we have got the mileage. Now suppose I say if I want this mileage, what can be the weight of my car? For example, now let's try out. So now I say model 1 is equal to, I am going to change this formula. So I say weight and MPG. Okay. Yes. So now let's try predicting it. So I say model 1 and I say data dot frame. Instead of weight, I am going to give the mileage MPG. Suppose my mileage I want it to be 32. Very high mileage, right? See. So it says the weight of your car has to be only 1.53. So based on this you can design. So these can be used by even automotive sectors or automotive industries where they can predict if I want this mileage, what has to be the weight. If I want this mileage, what has to be the number of cylinders. All these. Fine? Yes. So this is how you can work on with linear regression model in R. See, it is very easy. Just a single line statement, it will create your own model based on the sample values available and you can predict the values for the newer one. Yes. So try working out with so many varieties of data frames which are already available. We know that there is another data frame or a data set which we call it as air quality. From that you can try subsetting something and build a data frame, and you also go for converting your XML data into a data frame and try working on with these models. If you still have any doubts, you can very well contact me. Thank you.